equations, and we're going to really start with the easy kind. We're going to start with a kind that fit into this mold, where I can have the same base on both sides of an equation. Now, later on, we're going to talk about what do we do when we don't have the same base, because we can't always have the same base. But today, we're going to work with ones where you can. So, your first step is to write both sides with the same base. Okay, now when we do that, we always try with a smaller number first. Sometimes that doesn't work, and we'll talk about what to do when it doesn't. Okay, and then step 2 is to set the exponents equal. And solve. So that's really all there is to it. Okay, so you're going to look at number 1 and you're going to go, Miss Wilby, the answer is 3. And when that happens, you really don't have to do anything. So when you see a problem like this on the SAT or ACT and you can look at it and know the answer, you do not have to do all this work. But I'm going to show you with the really easy problems that we already know the answer to, so that when we get to the harder problems, that they make sense too. All right, so we have 2 bases here, 8 and 2. So we're going to try to write both sides with that smaller number. Can we write 8 as a power of 2? All right, let's look at our chart. Can we write 8 as a power of 2? Yeah, 8 is 2 to the 3rd. Okay, so once we have them written with the same base, then we just set the exponents equal and solve. Well, when we set the exponents equal on this problem, we are done. That's it. That's all there is to it. Whoops, that's the next one. Okay, so number 2, 4 to the x and 1/16. So if we look at just the numbers, 4 and 16, we can write this one as 4 to the -2nd. You were right. What does the negative do? The negative flips it. So when we have a fraction, we're going to end up with a negative there. So x equals -2. Okay. Now, okay, so what we're going to do first is we're going to look at the 2 numbers and we're going to try to write the bigger one as a power of the smaller one. Can we write 27 as a power of 3? Yes, it's 3 to what power? 3 to the 3rd. So we get 2x minus 3 equals 3. So once you write it with the same base, then you set the exponents equal to each other. I said solve. That should be set. That made no sense. Y'all are so sweet. Not so. When I said the directions, I said set, but then I wrote solve. We set the exponents equal to each other and then solved. So setting the exponents equal, we're there, and now we have to solve. So to solve, we would add the 3, and we get 2x equals 6, and then we would divide by 2, so we get x equals 3. All right, so this is really a skill. We are developing and refining a skill. And lots of times skills are easier than problem solving. And I think it is in this case. So even though we might get slightly more challenging problems, we work them all the same way. So let's look at number 4. So we got more in terms of our exponents this time, but it doesn't change what we do. So we have 5 and 25. Those are our two bases. Can I write 25 as a power of 5? Yes. So that's what I do. So it's 5 to the x plus 4 equals 5 squared to the x minus 1. I want to do a timeout real quick, and I want you to notice. On this side, I didn't change the value, and on the right side, I also did not change the value. Because isn't 5 squared 25? Yeah. So we can't change the value of either side. We can change its form, but we can't change its value. So always ask your, just kind of give yourself a quick mental check. Does what I just wrote equal what I started with? And the answer should always be yes. Okay, so now, this time on the right side, I have a power raised to a power. What do we do with exponents when we have a power raised to a power? We multiply them. So we're going to have to distribute that too. So what we get is 5 to the 2x minus 2 is equal to 5 to the x plus 4. So now we have the same base, and we set the exponents equal, and we just solve. So we're going to subtract x. We're going to add 2. So I get 6 equals x. Okay, so on number 5, on the left side I have 2, but on the right side I have 1/2. How can I rewrite 1/2 with a base of 2? 2 to what power? That's right. So when we have a fraction, that exponent needs to become negative. And so we get x plus 2 equals negative 1. So x equals negative 3. All right, when you look at 49 and 1/7, what common base comes to mind? What number are you thinking about? 7, right. 49 is 7 squared. So I didn't change the value because 49 is 7 squared. And 1/7 is 7 to what power? Negative 1. So on this one, we're going to have to distribute here and distribute here. So we get 7 to the 2x minus 10 and 7 to the negative x minus 1. So 2x minus 10 equals negative x minus 1. So we're going to move our variables to one side and our numbers to the other. And I get 3x equals 9. Now, I'm not going to always get something that divides real pretty, like in your regular class on your homework tonight. You might end up with something like right there that is 7x equals 3, so your answer is 3/7. That's fine. That's a good answer. It's okay if it doesn't divide out pretty every time. You can have fractions. Okay? So when you're doing your homework in there, if you get fractions, that doesn't mean you're wrong. Some of them are fractions, the answers. Okay. We're going to look at a few more situations because some of them work out differently. Yeah, we're definitely doing number 9. I feel like number 9 is straight off your worksheet for the other class. It is.
I'm kind of confused by number 7 because you get 5 to the negative second power. Yeah. And then 5.
I'm actually going to add some others down here too. We're going to, some odd ones, weird ones. We'll talk about those in a minute. All right, so this one, 1/25 and 1/25. What do you think about as a common base? 5. So 1/25 is 5 to a negative, because it's a fraction, negative what? Square. Very good, negative 2. 25 is 5 to the third. So this is our first one where our answer is a fraction. We get 5 to the negative second equals 5 to the 3x. So negative 2 equals 3x. So when we divide by 3 to solve, we get negative 2/3 is our answer. And that's perfectly fine. Okay, I want you to try number 8 so I can walk around and help those that need help. And then this one's unique, so we can do number 9 together again. So let me know if you have questions about number 8, and I'll pause the video. So for this one, we could write both sides with a base of 6. One of them was already 6. So we'll go ahead and rewrite this left side so that it also has a base of 6 because 36 is 6 squared. And so this is 6 to the 5 minus x. So what we end up here with is 6 to the, we have to distribute, so we get 6 minus 2x equals 6 to the 5 minus x. So our equation that we're solving, once we set the exponents equal, is this. So we'll move our variables to one side, our numbers to the other, and I'm just going to do it in one big step. So if I subtract 5, that 6 becomes a 1. If I add 2x, that becomes a positive 1. So we get x equals 1. Now, number 9 is interesting. Hopefully you remember 225 is 15 squared. Do you remember that from memorizing your perfect squares 1 to 20? So 225 is 15 squared. And I really like this problem because it ties back in sort of what we just did with our rational exponents. Now, this is 15 to the understood first power. So if you don't need to change anything, you put a 1 right there. All right? So now we get 2x equals 1. So x is 1/2. Now, does a rational exponent of 1/2, doesn't that mean the same thing as square root? Yeah, a rational exponent of 1/2 means square root. And the square root of 225 is 15. So some of you might even be able to look at it and go, oh, that's square root. So square root is the 1/2 power. Boom. Good. Okay, do you think you can finish these off? All right, let's try 10, 11, 12 then. And then I'm going to give you, and then we're going to do 2 or 3 more that are interesting ones, where we have to think differently about them.
Because all 3 of us are on a queen size bed. So you're
They go up to 95 degrees. You step on them, it's so good.
Alright, he has an issue with electricity and water.
Oh yeah.
Because if you have a leak,
because you just
you can have
We
a
actually
fire.
did have a leak in my
So-
bathroom though. With
Yeah.
leaking the floors and nothing happened. So.
Oh, cool. Alright, so we rewrite 8 as 2 to the 3rd. And so we get x equals 3x minus 12. So we're going to have to move the variable over here. So x equals negative 6. How is number 10? Good. All right, so this becomes 3 to the 4th. And we probably don't know all of our powers of 4. So you can use that chart. These types of problems will be on a no calculator part of a test or quiz. So if we give you the higher powers, we'll give you the chart. And then finally, number 12. So we get x plus 3 equals 3x minus 3. So if I move the x over here and move the 3 over here, we get 6 equals 2x, so 3 equals x. Yes, sir?
For number 7, I didn't get negative 6. I just got 6.
Okay. Oh, that's because I dropped the negative. Thank you. You were right. I dropped my negative on the 12. Good catch. All right, so let's do some of the weird ones now. So the first weird one. Let's do this. 5 to the 2x plus 3 equals 1. Well, if I go with, I'm going to write the bigger number as a power of the smaller. 1 to any power is still 1. So that's not going to work for me. So is it possible to rewrite 1 as a power of 5? Any number to the 0 power is 1. So if I give you one like this, you need to rewrite whatever, this 1 as whatever this base is to the 0 power. So we have 2x plus 3 equals 0. So 2x equals negative 3. So that makes x negative 3 halves. Okay, so that's our first weird one. All right, and there's one like that on your homework in your regular class tonight, so be on the lookout for it. Now, another thing that you can run into is where I can't write 8 as a power of 4. So what happens when I can't write this one as a power of that one, the next thing I try is, can I write both of them as a power of the same number? Okay, what could be a common base? 2. So when you can't write the bigger one as a power of the smaller one, you have to find a different common base. 4 is 2 squared. 8 is 2 to the 3rd. All right, so this becomes 2 to the 2x minus 6 equals 2 to the 6x plus 3. So 2x minus 6 equals 6x plus 3. And we solve. So we would subtract 2x, subtract the 3. So we get negative 9 equals 4x. And our answer is negative 9/4. All right, so that's today's lesson in math. Does that make sense? All right, we were going to do a little review, and that's what's on the back of those notes, but I have decided not to do the review and to move on to tomorrow's lesson, because today's lesson is not very difficult, and that way you get a preview of tomorrow. Okay? All right. So tomorrow's lesson is leading us into what do we do when we can't write them with like bases. So it's baby step 1.
Oh, I didn't understand proofs at all. They don't make sense like at all. Like at all. If we get proofs this year, you're so stupid.
Oh no. I saved day 2 on top of day 1. I just handed you day 2 notes, didn't I?
Yeah.
Yeah.
What isn't it? Isn't it?
All right, we're going with this. It's all good. All right, so today's notes. So we just worked on solving using like bases. But what happens when we get an equation like that? Is it possible to write 5 with a base of 2? Or 2 with a base of 5?
Nope.
No. So we have to have a way of solving exponential equations when we can't write them using the same base. The same base is pretty easy. It's pretty nice. But not all equations fit into that pretty little form. Okay? So what that develops is something called logarithm. This form is called exponential form. And with exponential form, there we go. We have a base raised to an exponent equals an answer part. So this is how I say it every time. A base raised to an exponent equals an answer. Okay, so an example of something that's an exponential form would be like 2 to the 3rd equals 8. Or 5 to the x equals 20. Or x to the y equals z. Do you see that all of those are in exponential form? We have a base raised to an exponent equal to an answer. A base raised to an exponent equal to an answer. A base raised to an exponent equal to an answer. So all of those are in exponential form. Now, if our exponent happens to be a variable, like this one, or like the one we started with, and that variable is something that we cannot solve for using like bases, then we have to have another method to solve for that. And this is brand new. What we use to solve for a variable is called a logarithm. And so we'll have logarithmic form. Okay, so this is exponential, the one we're used to. The one we've been doing since 9th grade. But we have to have a way to solve these equations. And that way is using logarithms. So we have to understand logarithmic form. So I'm going to write in blue what never changes. And I'm also going to put a little line like it's notebook paper, okay? So if this were my notebook paper, right here, and I'm going to write on this line the way it looks. All right, so this is log form. Log goes here. The base is a subscript. Subscript means slightly lower, doesn't it? The answer part goes here. And the cool thing about a logarithm is it solves for the exponent. So, when we get these crazy things, like 2 to the x equals 5, and we're trying to solve them, we're going to switch them to log form because a logarithm solves for the exponent. It solves for the exponent. So whenever you're trying to solve for an exponent and you can't use like bases, that's what we got to do. Okay, so let's go back to these examples we already started with, and I'm just going to draw lines here because I want to make sure. That's not straight, is it? Oh, you're laughing. It's bad off then. Okay, so I'm going to draw lines like I'm writing on lined paper, just like you guys are. So let's see. That's better. All right, so my next one I'll put on a oh, you guys aren't writing on lined paper. You're writing on the notes I just gave you. Okay, so if we were writing on notebook paper, this is what it would look like. So this is exponential form. Log form always starts off log, goes here. The base part is your subscript. So the base, which is 2, goes here. The answer part is here, and it equals the exponent. And that's how it would look. Okay, let's do another one. Log, on this one, what is my base? 5, so the base goes here. What is the answer part? 20, and it solves for the exponent. It equals the exponent. What's the exponent? X.
Wait, so that's supposed to be the answer for the whole one?
So X is log base 5 of 20. All right, this one's all variables. That's not nice. What is your base on this one? X. What is the answer part?
Z.
Z. And it equals the exponent. What is the exponent?
Y.
Y. Okay. So eventually, we're going to solve some really cool problems. Real world problems using logarithms. But to start with, we just have to get comfortable with them. They're brand new. It looks weird. So, today we're just going to practice going back and forth in between forms. So, if you look at your worksheet that I passed out, okay, the second worksheet. Does everybody have the second one? Did I pass out the second one? Yes. Okay. All right, so the first problem is log base 12 of 144 equals 2. Okay, so we're going to now write this in exponential form. So the base is down here, 12. The exponent is what it equals, 2. And then equals the answer. So we go from base, we switch in between these two forms. Log base b of a equals x, and b to the x equals a. We're just switching in between the two forms. That's not 140. There we go. Okay, so in number 2, what's my base? 5. Exponent? 6. And answer is 15,625. Okay. Number 3, I want you to try number 3 on your own. Alright, so the base is 21, the exponent is 3, the answer is 9261. Okay, so that's going from log form to exponential form. Now, I'm going to skip 4, 5, and 6. I know some of you have already done them, and that's awesome. But I'm going to come down here to 7, 8, 9. So these are in exponential form, and let's see if we can go the other way with it, to switch it into logarithmic form. Sometimes I just write the word log for logarithmic form. Alright, so logarithmic form always starts with log. And let me draw in my line. Like this is my sheet of paper. Straight-ish? Okay. Alright, so alright, so I'm going to write log on the line. My base is 19, so 19 goes right here. It's a subscript. It's a little below. The answer part is 361 equals the exponent. Okay, so you try 8 and 9. Alright, so this becomes log. My base is 20. My answer is 8,000, and my exponent is 3. Log. My base is 3,375. My answer is 15, and my exponent is 1/3. What root does an exponent of 1/3 equate to? Cubed root. Very good. So what this means is the cubed root of 3,375 is 15. Okay? All right. I think that's good for today. And then tomorrow we'll work on some solving with logs.